Let's go through LeetCode 3-star and 160. Find the number of distinct colors among the balls. For this question, it gives us integer limit. So that means there are limit plus one balls. And we can consider the limit is a ball's index. And also queries. For this query, what it do is that for every array the query, what it do is that it will mark the query 0 ball to be color query 1. So it asks after every query, what it will be how many distinct colors among all of the balls. Initially, set the ball's color to be is not colored. So let's look at the example. We set ball 1 with color 4, right? And then we set ball 2 with color 5. And so there are 1 distinct color, 2 distinct color. Then what we do is that we set ball 1 with color 3. So there are still two, right? Because the 4 is being replaced with 3. And the next operation is that we mark ball 3 with color 4, right? So the thing is that you'll see now there are 3 distinct colors because original the 4 has been removed, right? So what we're thinking about is that we need to look at how many distinct colors we have, right? So for the colors, we need to have its counts, right? So that for every color, we need to have its counts. So that when there is a color which is not in our data structure, and we are get this one from 0 to 1, right? So we add one more distinct color. And also why we need accounts, because sometimes, for example, we have a color 4 replaced by 3, right? So the color 4 originally it appears once, and now we replace with 3, right? So that means this color 4 will be changed, be times 0, and 3 is has time 1, right? In this case, we know if there is the color with count 0, we should remove this color 4 from this kind of data structure, right? So what we're thinking about with color with counts is that use a map, right? Map key will be the color index. The value will be an integer, which is the color counts. When the color counts becomes 0, we should remove from the map so that we can use the O1 operation to get how many entries of the map that is our distinct color, right? And also, we know there is a limit, right? So we know the balls are from index from 0 to limit. And we should also keep track of those balls. Why we should another data structure to keep track of the balls? Because we for example, we need to know, for example, ball 1, it is being replaced from 3 to 4, right? So for every ball, we should record its color. So we can use either an array, right? Array to record the ball's color. And when this one is not, we'll say initially is 0, right? And because what we set that is color should not be should be a number greater than 0. If it's not greater than 0, we can set up for the -1, right? Uh, but the thing is that we need every ball to keep its color. The reason is that if it's not marked, there is no color initially. Then what we need is just in our color map to add one count to this color map, right? And if, for example, originally it has color 3, then it is being replaced with 4. What we do is that we'll say this ball has color 3 changed to 4. That means the color 3 counts has been removed, decreased by 1, right? So we need to based on this kind of array to update the color map, right? So what we do is that we check the ball whether it has color or not. So we need another data structure, but use an array or we can use a map. For this question, it's better we have a map to record the color. The reason is you'll see the limit is 10 to the power 9, right? So if we have 10 to power 9 array, it will be 10 to the power 9 space complexity, right? So whether we use array or use map, we should look at how many balls and how many queries, right? Because if we use a map, that means only query number or at most query number of balls will be colored, right? So the use map, the time complexity will be for example, the query number is n, right? Will be O(n). But use array, the space will be O limit, right? Space. And then this one space is also O(n). So whether we use array or use map depends on which one is greater. For this question, we can use 2 maps. So let's write a code for this. We need first map is color to counts. And we need another map is ball to color. So what we do is that let's just get n equals queries data length, and our result equals new int n. So for int I equals 0, I smaller than n, I plus plus. So we get for each query, right? Each query is queries I. So there are 2 scenarios. Is that this ball already have color. We need to check ball to color map, right? So if we already have color, then color to count, so we need to decrease the original color by 1, right? If it does not, then we just add the counts, right? We can use the map merge or compute if absent those kind of functions to add a count. But since that if we already have color, we should remove the original color counts. And also, if the original color counts is 1, we should also remove the entries. So what we do is that if ball to color contains key query 0, we can have in the previous color, right? Equals ball to to color get query 0. And we'll have color to count. We can use merge p color -1 integer dot sum. You can also use computative absence. Get or default, right? Put get default, and but use merge will be simpler. So that means that if color to count get p color, if this one change to 0, right, we should remove this entry. So color to count, just remove this kind of p color. So no matter with original there have the ball is colored or not, right? We should always add a new color. So that is color to count merge query 1, right? New color and 1 integer dot sum. And we should also record this ball's color. So ball to color put query 0 and query 1. Use put is that if there is no such entries, we add a new entry. If there is such an entry, that is the first condition. If it is satisfies, we update to a new color, right? So result will be color to count dot size. And in the end, return result. It will be O(n) time complexity with O(n) space complexity. N is the length of query. And Python code will be very similar, right? We need two map. One called ball to color, another called color to count. And we can have n get n out, right? N equals length dot queries. So we're going to have result equals this one multiplied by n. So for I in range n, what we do is that query equals queries I. So if query if query 0 in ball to color, that means this ball have some painted color. So we need to get the previous color, right? Previous color equals ball to color get query 0. It's not gate, right? This is use this. So color to count T color will be decreased by 1, right? So we'll say for this kind of color to count P color equals to 0, we need to remove from the entry, right? Delete color to count P color. So this is when this ball have a previous color, right? Otherwise, what we do is that we have color to count query 1 should increase by 1, right? And ball to color query 0 equals query 1. And the result I should be length color to count. In the end, just return result. Line 3. Color to count. The things that is possible, this one will be 0, right? So let's do this. Color to count. Get our default, right? That is get query 1. Initial set as 0. That's 1, right? So because if it does not exist, that is add a new entry to this map.